talk about everything you need to know about acids and bases. Since the dawn of time, we've been told that acids are hydrogen donors, bases are hydrogen acceptors. But when you get to second year organic chemistry, you realize that's not always the case. Sometimes there's no proton exchange. So who's my base and who's my acid? What we have to do is we have to redefine the definition of an acid and a base. And in simple terms, the base is the thing that donates an electron pair, hence it's the thing with the electrons. It's the electron-rich thing. What's that? It's the nucleophile. The acid is the electron pair acceptor, so it was the thing that got attacked. Hence, bases are the nucleophiles and acids are the electrophiles. So the arrows in organic chemistry for Lewis acids and bases always go from the back of the arrow starts at the base and the head of the arrow ends at the acid. Let's do an example. The first example will involve the exchange of a hydrogen. The second will not. So an amine reacts with HCl. Step 1, label in your partial charges. So H on HCl is going to be delta plus, chlorine delta minus, because chlorine is electronegative, pulls electrons towards itself. The NH2 group has a lone pair, hence it can be nucleophilic. It can attack 2 in to the H in HCl, 2 out. Look at the products. Chlorine, which initially had 3 sets of lone pairs, now has 4, hence it gained an electron pair. Hence HCl was the acid. It lost an H, but it also gained an electron pair. Whereas the base, NH2, with its substituent, gained a hydrogen, but it also had a lone pair where those 2 electrons in the product side are now in a bond. Hence it lost an electron pair. It donated an electron pair. Whatever makes more sense to you. So now let's do an example where there's no hydrogen exchange, but we can still label Lewis acids and bases. For example, let's react an amine with BH3. So boron, if we draw it out, it has 3 valence electrons. Hence it's neutral when it has 3 bonds, but its octet isn't full. It has 6 electrons in the octet, hence it can be attacked with no 2 out because it does not have a filled octet. So NH2 with its lone pair can go 2 in, hit the boron. Look at the products. Boron accepted an electron pair, hence it was the acid. NH2 and its substituent donated an electron pair, made a bond to the boron, hence it was the base. Nucleophile to electrophile. Lewis, base, acid. Quick maths. Hopefully that helped. Let me know if you have any questions.